Good morning, everyone, and thank you for joining. If this is the first time that you're tuning into our webinar series, my name is Fred Senekal. I'm the head of R&D here at Learning Machines, and I'll be hosting you for this webinar. So this webinar being hosted by our company called Learning Machines. We're a consulting firm. We specialize in a number of services, including machine learning, big data, and cloud services. And if you want to learn a little bit more about what we do, you're most welcome to go to our website at www.learningmachines.co.za. All right, so for those that just joined, this is the fourth webinar in a 5-part series. In this series, we're investigating the application of AI and machine learning, specifically to unstructured data. So in the previous webinars, we had a look at text, we had a look at voice, and this webinar and the next one will look at imagery data and how to process imagery data. So today, we're going to have a look specifically at OCR, which is also known as optical character recognition and document processing. Now, if you want to tune into any of our other webinars, the next one will be in 2 weeks, which will be on image and video processing. I'm quite looking forward to that one, and I'm sure it will be interesting to you as well. So if you want to visit that webinar, please just go to our website and register. All right, so today we're taking a look at optical character recognition. And we're specifically going to talk about Amazon Pixtract, which is a service from AWS. If you want to ask questions, you're more than welcome to do so in the chat window, but there will also be a Q&A session at the end. And you're welcome to wait until the Q&A session, but you're also welcome to ask questions in the chat window. And some of my colleagues will try and answer your questions to the best of their ability. All right, so maybe let's start off with just talking a little bit about OCR and trying to give a definition for it. And so really, when we talk about OCR, it's about the conversion of images of documents and converting those images of documents into some form of a text representation, which we can then use for further processing in downstream workflows. And of course, the documents that we generate images of can be things like typed text, so text that was generated by a computer. It could be handwritten, and if it's handwritten, it could either be sort of in a printed form or in cursive text, doesn't matter. The objective is to be able to get some understanding of these images and then to create a text representation from those documents. Now, sometimes people refer to the portion that takes handwritten input as intelligent character recognition, and trying to differentiate it a bit from optical character recognition, in the sense that when you talk about ICR, it's for handwritten characters and OCR for typed text or computer text. And there's a slight distinction there. So if someone is talking about OCR, just be aware of the distinction. Now let's look at a typical OCR workflow. And obviously, the start point of this would be some form of a document. And there's different types of documents, and I'll show you lots of examples throughout this specific webinar. So it can be an invoice, it could be a bank statement, it could be a tax form, it could be lots of different things. And we start with this document. Typically, we then take some form of scanning equipment, which will then digitize the document into an image representation. And the benefit of using something like a dedicated scanning device is, of course, that you have control over things like lighting conditions. The document remains stationary. And also, you eliminate a lot of some of the artifacts that might be present in other forms of digitization, which typically would result in a higher quality image. But with people, consumers especially, having access to different types of devices, smartphones and cameras and this type of thing, It's becoming sort of, in business workflows, people start to expect that you would be able to take a sort of your camera phone and you can digitize a document and send it on to an organization. So there's also different other ways of creating an image of a document. Of course, when you have like something like a smartphone camera, a lot less control over the quality of the document, which might influence your downstream processes. All right, so now we have an image, and we will now apply some form of an OCR algorithm to be able to create a text representation of that image. Now, if you're quite unfamiliar with what is these types of representations on a computer, and the difference maybe between an image and text, you know, if a human looks at an image, it's fairly easy for us to kind of see all the different text letters that's on that image. Much more difficult for a computer to do so. So, as many of you might be aware, image, of course, being composed of lots of individual pixels, which is essentially just a bunch of numbers, and the computer has to really analyze those numbers in order to extract the text that's present within that image. So let's look at a couple of business use cases for OCR and see where one might apply something like OCR. And obviously, the first thing that comes to mind is as a form of data entry. The ability to use OCR to input text that might be on a document in order to streamline your document processing workflows. And the idea there would be to have as little as possible human intervention. Of course, humans, if they have to manually capture data, it's quite slow. It's probably quite expensive to pay humans to do all the work. And it's probably quite prone to errors. So you might expect that humans getting tired might make a couple of mistakes. If you think about business use cases for OCR, we were talking about document processing workflows. And there's really a large number of different types of documents that can be processed. If you think about in your organization, things like bank statements or invoices or tax documents, these types of documents probably take quite a long time for your finance staff to digitize. Something like an invoice where you have different line items that need to be digitized, or bank statements, many companies sort of printing these out and then going through them one by one and entering the different types of debits and credits, and taking quite a long time to do so. And so obviously by using OCR, we can eliminate quite a bit of these sort of time-consuming jobs. And obviously as well, hopefully there will be quite an improvement in the accuracy of the digitization. If you think about document search indexes, so documents that's just in a scanned form is probably not searchable within the organization. And so by creating a repository of searchable documents, you make these documents accessible to employees within your organization. A good example of this might be something like Google Books, where entire libraries are being digitized and millions of books becoming accessible to a wide audience out there. Of course, your documents also need to comply to a number of different requirements. And so documents might end up in a document warehouse, and these document warehouses would typically offer some form of scanning and OCR being applied so that your documents can easily be retrieved if you need to refer to them later on. And of course, there might be some regulations in place. So you might need to redact personally identifiable information if you're going to scan it. And so OCR also gives you the ability then to scan documents and identify some sensitive information. Now, if you've ever been on an airplane and you had to enter your flight ticket somewhere, you've probably used the OCR system before. And so validation systems is quite a large area, quite a large use case for OCR systems. anything from tickets, ID documents, coupons, licenses that's being scanned. Especially if you live in an estate in South Africa, if you think about someone using a scanner to scan your license disc, the principles inside that license, inside the scanner, is the same as the principles being applied in OCR. Now, probably one of the greatest uses of OCR is in terms of things like automation. If you think about post offices and mail automation, the ability to read the addresses that's contained on envelopes and parcels, things like waybills in logistics. And also if you go to a shopping mall, all the barcodes that's printed on products is a form of OCR that takes place to be able to scan the barcodes and then associate pricing information with the product. And then, of course, OCR is usually the first step in natural language processing. So downstream, there might be many different applications of the extracted text, things like document classification or translation and so forth. People starting to use OCR systems in automated examinations. And maybe a good example of that is the Washington Post, which obviously deals with a large volume of public documents that they need to read in, and they use it as a first step to find entities and to be able to verify facts about the world. Now, the offering that we'll be talking about today is called Amazon Pixtract. It's a fully managed machine learning service from AWS. It's been generally available since May 2019. And really what it is an off-the-shelf AI tool, like many of the other tools we've discussed so far in this webinar series, such as Comprehend or Lex or Kendra, and that we will be discussing in the next webinar as well. It uses a pre-trained and continually updating machine learning model, which does not require any training on your side. So you can use the service off the shelf with very little inputs from your side. Now, maybe what's exciting about Amazon Pixtract is that it doesn't only do optical character recognition, but it also gives you the ability to perform document analysis, which allows you to be able to extract forms and tables from within a document. And I'll show you quite a number of these examples as we go along. There's a number of key features for Amazon Pixtract. So we've talked about optical character recognition and document analysis, but it also gives you the ability to do this in a real-time or in a batch mode. It interfaces with things like Amazon Augmented AI, so that you can apply human review to the results that's achieved. It gives you confidence values, and it's quite affordable. And I will talk about each one of these features during the course of this webinar. So the first one being optical character recognition, which I'm sure you've heard about before. And basically what it does is, first of all, to be able to detect printed text and numbers in a scan or in a document rendering. And you needn't select the area where the text exists in the document. So Amazon Pixtract will automatically detect the areas in the document where the text occurs, and then extract that text for you for further processing. Now, what I should maybe say at the onset is that unfortunately at this stage, Amazon Pixtract only works on typed text. So text with well-formed fonts. It unfortunately does not support handwritten documents, which unfortunately, I guess, limits the use cases for Pixtract to quite an extent. I'm sure it's something that the engineers over at AWS will look into for future. At the moment, it can extract characters from the Latin scripts and ASCII symbols. And so it's really geared towards sort of English type languages. But what's also quite nice about Amazon Pixtract is the ability to extract different forms of data representation. One of them being data that's represented in a tabular form. So if you think about things like financial statements or financial reports or invoices or medical reports, all of these types of documents are typically represented in some form of a table format. And so in Pixtract, you don't need to specify where in your document these tables occur. It will automatically infer the structure of these tables and extract it for you so that you can use it in things like your databases and so forth. Another ability of Pixtract is to be able to extract forms, form data which may be present in a document. So for instance, things which are represented in key value pairs, like the name of a person, or his address or telephone number or ID documents and so forth. Now, quite a couple of other types of OCR systems might require you to do a manual configuration of where to pick values within your documents. And each time a document layout changes, you will need to then update those layout formats in those OCR packages. With Pixtract, it's not necessary. It automatically detects the layout of your form, and so there's no manual configuration or updates that you need to do. So if we just briefly look at the different supported input documents and operation modes, there's quite a couple. So JPEG and PNG file formats is quite familiar. Many scans will digitize documents into JPEG format. And also PDF documents, which I think is the de facto standard on the web for exchanging documents. There's some usage limitations. So JPEG and PNG files can go up to 10 meg, while a PDF document can go up to 500 meg. Now, Pixtract supports both synchronous and asynchronous operations. So synchronous is typically where you want to digitize a document in real time. So someone, say, uploads a document and you want to be able to extract text from that document in real time. And you can do it through their synchronous interface. At this stage, it only supports JPEG and PNG files. And you would typically use some form of a base 64 encoding to execute the real-time operation. Now, if you have a large number of documents, you typically want some form of asynchronous batch mode to be able to process the documents. And what you would typically do is to upload them into Amazon S3, which is their storage solution. And from there, a batch job can be kicked off and the documents will be processed with the results being put back into S3. Obviously, for best processing results, there's a number of recommendations. So first one being that documents should be scanned at a high resolution, which is typically about 150 dpi. That sort of gives you about 15 pixels or so for an 8-point font. So at least the font should be readable from a machine learning perspective. Now, there's two different APIs which enables you to process documents. The first one being the Detect Document Text API, which is made for the OCR portion of Amazon Pixtract, and the other one being the Analyze Document API, which is for extracting forms and tables from your document. And in response to a request to extract the text, a JSON response is returned. And this JSON response is really a number of different blocks about the different elements that's been found on the page. Now, at the highest level, there's a document, and that document consists of a number of pages. Now, JPEG and PNG file formats, which will count as a one page, while a PDF document, each one of the pages will be analyzed separate from all the others. A single page then consists of one or more lines, and each line consists of one or more words. And so you can see a whole hierarchy of different representations of the text being built up within a document. For key value pairs, the words that's associated with each key and value is extracted. And then for tables, the tables present in a page will be extracted and then represented as different cells. And each one of these cells will then consist again of a number of words or selection elements. A selection element being something like a checkbox or a radio button that has been ticked within a document. Now, in addition to these various blocks that's extracted on a page, you also get confidence values that are returned for each one of the blocks. And so the confidence value is a value between 0 and 100, which expresses the probability that a given prediction is correct. Now, depending on your use case, you might have different confidence thresholds that you set. So something like archival might require something as low as, say, 50% confidence, while if you're thinking about things like financial decisions, you might need a confidence value of 90 or higher. And based on these confidence values, you can then request that humans review the different blocks. So it's not just trusting the OCR mechanisms, you can also request that humans then review the different blocks, and I'll show you what that entails just now. Each one of the different blocks has associated geometry information. So there's a bounding box, and so referring back to your document is actually quite easy, and you can see where there was low confidence in predictions, which could then be given to humans as part of a review workflow. Now, Pixtract is directly integrated with another Amazon product called Amazon Augmented AI, or Amazon A2I. And what Amazon A2I provides you is a number of different workflows to associate the text that is extracted with different areas in your document, and then to ask humans to be able to review those blocks for you. And you can assign reviewers either from within your organization or from Amazon Mechanical Turk, which is their crowdsourced workforce, or from a number of screened workforce vendors that have specific training in reviewing OCR text. And there's a couple of strategies that you can apply. So first of all, you can have any predicted text that's below a certain threshold reviewed. You might randomly sample, which will allow auditing. And then, of course, if there's specific types of workflows that you feel is quite nuanced or sensitive, you might then also require humans to review those workflows for you. And doing all of this then gives you a balance between accuracy and cost effectiveness. And so you would choose thresholds that would both allow enough accuracy, but also then wouldn't be cost efficient. Now, of course, Pixtract has a number of security and compliance regulations that it adheres to. So obviously things like encryption at rest and in transit, and information and access management is taken care of for you. Also, quite a number of compliance regulations that is adhered to. So things like SOC, the Health Insurance Portability and Accountability Act, ISO, PCI, and GPDR, and so forth. In terms of costing, let's take a quick look at costing. And so, as I said before, there's two different APIs. So the one being the Detect Document Text API, which is for OCR only, and the other one being the Analyze Document API, which is for OCR with tables or forms. if we take a look at the cost there, it's maybe easiest to look at 1,000 pages or so. The cost for OCR being about $1.50 for 1,000 pages. And then the cost then for more specific things like your tables and forms would go up quite a bit. Now for JPEGs and PNG files, as I said before, these would count as a single page. And obviously a PDF document consisting of a number of pages, you would pay for each document for each page that's contained in your document. It's also quite a generous free tier, which is available for 3 months. For the OCR portion of it, you get up to 1,000 pages for free per month. And for the form and table extraction, you get up to 100 pages free per month. All right, so let's maybe take a look at some examples, which is more interesting. So I've run a couple of tests using Amazon Pixtract to see how well it performs. And I'm going to show you a couple of examples real quick. So the first one of my favorite books, Algorithms in C. And I took a random page there, this one being on the quicksort algorithm. And you can see on the right-hand side the different words that was extracted from that page. It did very well, highly accurate. 1 or 2 mistakes. Most notably in the title, it got the title wrong there. The word quicksort, it only said quicksort. And what is noticeable there is if you look at the font that was used to represent the Q there, it's almost like there is a little line below the Q. And so maybe the machine learning wasn't able to pick up on that specific font that was used there. The fonts within the page, of course, which has Qs that look more like Qs that we would expect, it had no trouble picking those up. Another noticeable slight mistake, if you look here at the N squared, Pixtract didn't make the association there with the superscript being part of a single word. It had those as 2 individual words. But overall, I think fairly accurate. I also did a test to see how the difference would be if I scan at different resolutions. So at 200 dpi was the first scan, and I also did at a lower resolution, about 100 dpi, and there was almost no difference in the resolutions, in the accuracy of the predicted text, even though the 100 dpi is quite a bit below the recommended minimum resolution for an image. I was wondering what would happen if we have rotated text. So I gave a image here with the page rotated at 90 degrees, and it did very well. Also being able to extract the different lines of text without any hassles. In this case, I rotated the page by 45 degrees. And I think quite to my surprise here, I found that Amazon Pixtract was still able to extract all the text, although the best practices say that this probably isn't possible. But in my experimentation, I found that it is actually quite possible and actually quite accurate. Let's move on to something a bit more interesting. Here we have a newspaper article. There's quite a number of variations in the scanned background. So you can see sort of dark and light shaded areas. The quality of the newspaper is also, the quality of the paper itself isn't so grand. So there's maybe a bit of low contrast. And you can still see that Pixtract did quite a good job of extracting different text from the document. Unfortunately, here, not getting the title from the newspaper article extracted. And I suspect that it might have to do with the different scales at which it tries to match characters within a document. Also notably here is that if you look at the different lines that was extracted, this is a multi-column article. So there's 2 different columns. And so unfortunately, in post-processing, you will have to associate the different lines in the columns yourself. And I think that's maybe one area where Amazon Pixtract could probably improve a bit. The ability to create sort of columns and then group columns together with the text within those columns. But generally, also quite accurate. Let's take a different example. So what I did here, took one of our learning machines brochures, made a screenshot of it, and Amazon Pixtract had no problems to extract different text that's on this specific brochure. Now let's maybe take a bit of a more interesting example. Yeah, I took a page from a book, fairly good quality scan there. You can see a bit of graphics in the background. I'm trying to confuse maybe how the extraction algorithms might work, but it worked very well. Even in the bottom left corner here, you can see a slightly rotated piece of text, and the algorithms still managed to extract the text very accurately. But I think what's interesting about this example is that there are actually two different tables present. And so I was testing if Amazon Pixtract would be able to extract those tables for me. And what you can see here is that not only did it extract the text very well and aligned them sort of in different columns with correct extractions, it also gave me the bounding boxes for where the different cells are within the table. And notably, I didn't have to configure anything to be able to get the table extracted here. There's also a second table present, and again, the table that was extracted and the alignment of the different cells to the table here has been done very, very well. So let's do something a bit more serious. So what I did here is to look at the integrated report of Eskom for 2019, and specifically the page where they list all their KPIs and which KPIs have been reached or not. Sadly, quite a number of red dots there, but I guess in fairness, also a number of green dots. And so first of all, if we just run the OCR algorithm here, you can see that it actually managed to detect all of the text elements that's present on the page. So line by line and all the different values and KPIs that had to be reached. And it managed to be able to extract all of those. However, I was interested in seeing if we could extract a table from this report. And as you can see here, Pixtract analyzed the structure, and we're able to sort of create this table overlay, and I think it quite fairly represents the different fields and cells that's present in this table. So again, quite a good extraction on this type of document. Now here's a slightly different example. What I did here is to scan a page from the yellow pages with different names of restaurants and the associated telephone numbers. And again, here the paper quality is quite bad. You can see the yellow background, low contrast, some dark shaded areas. And again, Pixtract did quite a good job of extracting sort of the associations between the different restaurants and their telephone numbers, although it did make quite a number of mistakes. So here was a couple of examples with missing digits or superfluous digits. Fairly good at the different names of the different restaurants and their addresses to extract them. Now, notably here, I think it did quite a good job of trying to associate some form of a table with the data. If you look at the text here, there's a bit of overflow into the portion where the different telephone numbers are presented. And so Pixtract did quite a good job of sort of correctly breaking those up into different cells. So maybe not the most accurate extraction here, but still quite a fair job. All right, so let's take a look at one or two examples of how we might be able to extract a form from data. What I did here, I presented Pixtract with a blank form from SARS, trying to see which are the different fields that has to be entered onto this form. And you can see from the overlay there that it managed to detect most of the different text fields and quite accurately where the user is supposed to enter text on them. Notably, it missed the surname field there, as well as maybe one or two lines of inputs there. And so that brought me to the idea that perhaps these forms should be filled out. So maybe let's take a look at a different type of form. And here is a example of a form that actually has values entered for each one of the open areas. This specifically is a employee eligibility verification form from Stanford. And so first of all, you can see if we just run the OCR process, able to extract all the different areas from the form quite accurately. And if we then take a look at the form values themselves being extracted, you can see that it actually did quite well. So it is able to extract things like email addresses, telephone numbers, dates of births, cities and towns, and so forth, and doing quite a fair job about it. Of course, if you are designing a form which you want to use in your business, you would then, of course, try and optimize this quite a bit and design the form in such a way that you know that the OCR process can do better at extracting these sort of different key and value pairs. Now, what I did here, a slightly different example. I took a standard invoice, something that I bought, and initially I made a mistake and I presented it to Pixtract the wrong way around. And again, to my surprise, still able to extract all the different text elements on this page. So for reference, if we just turn it around, you can see there that it was able to detect things, the logo there, things like the tax information, things like a slogan, and all the other text portions on this document. Now, what makes this document slightly more interesting is that there's both sort of form data on the document as well as tabular information. So if you look at some of the form extraction work that's being done here, you can see all the highlighted areas there, which looks like form bits. So telephone numbers, faxes, emails, deliveries, and so forth. And what's quite noticeable here is that there's different alignments. So in some cases, the key value pairs are horizontally distributed, and in other cases, they are vertically distributed. And you can see quite an accurate extraction here. So anything from the account numbers and telephone numbers and invoice dates and so forth being correctly extracted. Now, in addition to the form data, there's also some tabular data. And specifically, there are two items that was bought there. I see I bought an ink cartridge and a box of paper. And Pixtract then associated this middle portion here as a table, and were able to extract different cell values. Now, what puzzled me quite a bit here was the codes, and you can see they didn't do quite a good job of the code information here associated with each product. And I was wondering what this might be. So if you notice, the actual scan here is slightly rotated, and there's also, it seems like, a couple of additional information here in the table, maybe a bad scan. And so what I did was to just rotate the scanned image slightly. And based on that, it was then able to correctly identify the different item codes. So again, robust to some rotations, but you'll definitely get better results if you can accurately scan your pages. All right, and maybe as a final example, gave it a bit of mathematics from one of my calculus textbooks. Yeah, and it did a fair job. So the individual characters on the page, able to extract them. As you might expect, it struggled with some of the mathematical notation there. So things like the infinity symbol was modeled as a 0. Things like the delta character there was recognized as a S. It also missed a couple of things like the equal signs there and so on. But I think generally not too bad for a use case where it's really not meant to be applied. All right, so before we go over to the Q&A session, maybe just a reminder that learning machines, one of our core focus areas is cloud computing. And so if you would like to have a free evaluation of your organization's readiness to adopt cloud services, you can go to the website that's presented here at learningmachines.co.za/cloud services. We've prepared a questionnaire for you. And if you'd like to fill out the questionnaire, one of our solutions architects will provide you with a free cloud readiness report for your organization.